So when you do your closure capturing, you can have a capture list, and you can choose to have nothing at all, strongly capture things. You can choose to have unowned things or weak things. I think Apple prefers to have weak things because they're safer. I am a bit lazy and do unowned across the board, I think, pretty much.
Can you explain what it means?
I'll explain.
Oh, I'm sorry.
So if you have a strong capture inside a closure, it owns the memory, or at least has one handle to the memory, which means you can get into a hideous cycle sometimes. For example, if you had two robots cleaning the room, Roombas, and you said, robot A, stop cleaning when robot B stops cleaning, and B, stop cleaning when robot A stops cleaning, they never stop. Cycle. Yeah? The same is true of a strong reference cycle. If object A has a strong ownership of object B, and B strongly owns object A, they can't be released. So when you have a closure, if the closure is stored as a property to the view controller, for example, some view controller has a property saying, run this closure at some point, and the closure captures the view controller, you've got a problem. Now, mostly, for most of us, this is a non-problem. For example, UI view animate with duration is not going to do a strong capture. But even then, I prefer to do unowned self, just for my head, because it means at a glance I can whiz through and verify all my code. Yeah, there's no problems here. So by default, you get a strong capture, will own the RAM attached to it, own the object attached to it. Weak will have a reference to it, but it'll go away freely, just like a weak variable, if the object goes away. But you must use question mark everywhere. And unowned is like a sign Objective-C. It's no question mark required, but it can still go away. I use it because I'm lazy. Okay. Got through a fair amount, I think. I'm doing pretty well.
Are we voting now?
Well, I have to think first, but yeah. Go for it. Dive right in. Go.
Operator over there?
Operator.
Really? Brave. I love it. Anybody else? Operator overloading? Kimberly, can't hear you. What do you want to do? You've been so quiet. Sorry? I can't hear you.
Values versus references?
She's been quiet all morning, I think. So. Let's do values reference types, because this is actually more interesting than you think. It really is. People think this is easy, and it's not easy. So let's have a look. Values and references is about here. Values and references. This is actually very important, and it's also very awesome. Seriously, it's a critically important topic. This will screw you up if you get it wrong. They behave completely different to reference types. And the people who don't care are making a grave mistake. Now you can mix the two if you need to. But references should be a choice, not your default option. And if there was a talk tomorrow, which I'm not doing anymore, I'll go to more tomorrow, but I'm afraid I can't do it. So here's some examples. Hello is equal to hello. Of course it is. We know that. String reference value types works fine. Also, 1 plus 1 plus 3 is going to be 5, and 4 plus 2 minus 1 is 5. We can see, logically, that adds up. We don't care how you reach the number 5, 1 times 5, 10 minus 5, whatever. We don't care how you get there. 5 is always equal to 5. QED. So in terms of what Swift uses, the value types list is this. String, and integers, and arrays, and dictionaries, and sets, and doubles, and booleans, and enums, and tuples, and structs. So basically almost everything. almost everything. What isn't? Two things. Which ones?
Classes.
Classes and
Functions.
closures. Good. It's
I
an
want to say functions.
it's closures. Swift is an extraordinarily aggressive, value-oriented language. I'll show you some code. This code recreates a famous scene in a movie I'm sure most of you have seen already.
Princess Bride.
Close. It's just like Princess Bride, just as more sort of TIE fighters. Star Wars. Star Wars, the first one, which of course is the original one, A New Hope, which you all saw, I imagine, most of you are at least aware of. And in that film, there's some thing happening. They're attacking the Death Star in their X-Wings, right? So we create a target, and we say, okay, point at the Death Star. Luke, go for it. Attack the Death Star in your X-Wing. Do your trench run. Now, in the film, Luke is not alone. He's got his pal, Wedge Antilles. And Wedge comes with Luke and gets hit with one of the TIE fighters blast him. He has to fly back to Rebel Base. He goes, Luke, I'm sorry, flies away. So he goes back to Rebel Base, like this. And the question is, when that code is run, if we ask Luke and Wedge what their target was, what would they say?
Depends what type of target is.
Good. Depends what target is. If target was a struct, or if target was a class, the result of that code will be different, which matters. The difference is one word, struct or class. In the latter one, you'd have some really confused cinema goers as Luke bombs the Rebel base. Disaster. They both share the same target object. That's what reference types do. They point at the same reference to data, and they share it. So Luke's target and Wedge's target and other target, red 5, red 6, red 15, whatever it is down there, all point at the same target thing. Whereas with structs and value types in general, they have unique copies. Now this matters. Think about your apps right now. Your app will have lots of properties. Plus, it'll have a view controller, which itself has lots of properties. And that might push another view controller. And that view controller might point back to the first one as a delegate. When I'm finished, point back and have more properties. Might go even further, its own view controller. Push more, push more, push more. This is not uncommon. Again, the delegate pointing back plus other properties. This is extremely common. A navigation controller, push, 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 push if you're using iOS. And you might, but I'm sure you people totally don't, point back to your app delegate now and then. Like that. And what you can end up with is this fairly crazy situation where everything can literally see everything else in your entire app. It can see it and it can change it. Now we choose not to because we're good programmers, but it's still programmer choice. It's there. That Office Junior you just hired, first week out of school, I can just do this and change things completely. Now this means you can give a doctor an array of patients to work with. You can say patient, patient, patient. But at any point, another doctor come along, point at the same data, and say, that patient, lol. Change it. Change to both people, if you're not careful. Fortunately, this is hard to do in Swift, because Swift arrays are value types. So if you have var A equals 1, 2, 3, var B equals A, take a copy, then append 4 to A, and print b.count, B will still be 3, because there's a full copy, uniquely. Now you might think, this sounds terrible. There's stacks of copying happening for almost no reason most of the time, just passing data around. And to be fair, that's exactly how Objective-C had it working. There's actually a copy attribute in Objective-C just for this. It takes defensive copying all the time. It's extremely wasteful. Swift has a better solution. Multiple objects can point to the same array. Just fine. That's okay. As long as they don't try to change it. As soon as one of them tries to change the array, what happens is Swift takes a copy then and modifies the copy. It's called copy on write. And it'll happen again and again as needed. And if no one else is affected, if there's only one object pointed into the array, it'll change it in place. Go ahead.
Is there structural sharing?
Help me out. What does that mean?
Means that only copies the part that it needs to distinguish it from the original.
I see. I don't think so. I did try and read about that. I don't think so is the answer. I'm not sure. I don't think so. I remember reading about that same thing. Anyway, so you get safety and you get speed at the same time. So it's guaranteed to be safe, but if it can change it in place, it'll change it in place. So what value types give you is isolation. Each piece of data has only one owner, guaranteed. No one else can change it. It's not shared, like references. There are no surprise patient fish in there. There's no need for defensive copying because of copy on write. And you can write tests for it far easier. Everything works in isolation. There's no sharing of data being passed around. Plus, easy to debug because you can know no one else changed it. Problem must be here somewhere. And most importantly, it's easier to reason about, to think through in your head. Because you're splitting your code up into small, sensible chunks. But there are some advanced bits. One I showed you already, I won't repeat it here, closures of references. This causes problems, as you saw, modifying the same counter with Greek copy. You've seen it already. Second, boxing up structs is interesting, worth looking at. And immutability is different. And this is a major reason for switching to value types rather than reference types, is the immutability benefits. Are you all aware of boxing already or not? You know what boxing is? Boxing, anybody? Apart from, boxing. So, I'll show you. Much better to show you. So what I'm saying is that the benefits of using value types are pretty simple in terms of you get simpler code, you get isolated code, it's just nicer code generally, okay? But sometimes you're going to want to use reference types. You're going to want to share some data across the board, for whatever reason. And that's cool. So your app works 95% of the time using structs and enums and stuff, but 5% you think, I should use a class here so I could share it more easily and modify it, make it mutable and so forth. That's where boxing comes in. So I'll create a simple struct. Struct person. Var name string, var age int, and we'll do var favorite ice cream string. That's a simple person struct. And I'll create one of these. I'll say let Taylor equals person, name Taylor Swift, age 26, favorite ice cream. I have no idea. I'm not some sort of weird Taylor Swift stalker. Chocolate, probably. Let's face it. Now, if we wanted that struct to be shared in multiple places, pointing at the same value, we can do. We have to put the Taylor in a box. So we'd write this, final class person box. Oops. Var person is a person, and init, person, self.person equals person. And that takes the struct and places it inside a class which is a reference type. And we can pass that reference type around and thus share the struct, as what boxing does. And it's used in places like Java and C# to put primitives like ints and strings into things that want objects like arrays. It silently boxes and unboxes for you.
Which is like NS value and Cocoa?
Yes, NS value I try not to think about personally because it makes me wet the bed. But yes, in theory, it's like NS value. Thanks for that. Horrible dreams tonight anyway. So we can now put Taylor in the box. We can say let box equals person box, person Taylor. Boom. So this is a class around the person struct. So as a reference type, it will be shared rather than copied. And I'm going to create a test container so you can see how this looks and works. Sort of simulating what a view control would look like. If we had final class test container, var box, person box, we can now say let container 1 equals test container, let container 2 equals test container, and container 1 dot box equals box, and container 2 dot box equals box. So they're both pointing at the same box object, therefore they're both pointing at the same struct behind the scenes. We could prove it like this. We could say print container 1 dot box dot person dot name, print container 2 dot box person dot name, box dot person dot name equals not Taylor, and then print the same again. And you'll see they both change. So you're boxing. Put it in a box for the explicit reason of sharing it when otherwise it would not be shareable. So using structs is perfectly safe, and when you want to do it, you use this. Now, if you intend to use extensive use of boxing, obvious warning, you lose the benefits of structs and value types. Your call. A better idea is using generics. Because you replace this whole final class person box thing with box T, any kind of thing. And do var value T, value T, value, value. And now you can just do box person. And put a person in there, or an int in there, or a string in there, whatever you want. And pass it around. Any kind of struct will go in there now and be boxed up. So this thing will hold a box of person, like that. So you can box any kind of value type now if you really want to. Again, warning. So what's happening here is we are losing the safety of structs and value types, but gaining the ability to share it. And you might think, well, I can just use classes across the board. Where's the point using structs? I'm going to put a box in a box anyway. And what's changing here is, again, about your intent. And I've said it before, and I'll say it again. Making your intent clearer to other developers is hard, but important. And this makes your intent clearer. I don't share my stuff. I don't share, don't share, don't share, don't share. This bit is going in a box. I want it explicitly to be shared. You are telling the world reading your code, this is designed to be shared. If you use classes everywhere, is it designed to be shared? It's just you being lazy? You can't tell anymore. You lose that knowledge. So by being explicit about your code helps other developers. One warning, if you are familiar with the way ARC works, reference counting works, when a value goes in, a reference type goes in, it adds one to it and removes one when it can to free it up. If you have a struct which contains reference types, for example, let's make one up now, struct drawing board, var palette UI view, var board UI view, var paper UI view, whatever. A load of reference types in there. You've got a problem because the struct is not reference counted. Struct doesn't need to be reference counted. It's only owned once. There's always one reference. So there's no point in doing arc on structs, okay? So they're more efficient for that. But the UI views inside it do need to be reference counted. So when you pass the struct in, Swift can't arc up the struct. It has to add one for palette, and add one for board, and add one for paper. So now rather than 1 plus 1, you've got 3 plus 1s, or 10 plus 1s, or 20 plus 1s, you're reference counting. So if you have a situation where it has to do constantly adding and removing, you might think, okay, maybe it's time to switch to a class. Because if that were class drawing board, it'll add one to the drawing board object rather than all its properties individually. Know the options, choose intelligently, choose pragmatically, don't just reach for what you know. Last is immutability, which is important because Swift is aggressively immutable. We know this, right? If you did like, var I equals 10, print I, Swift will complain. It will say eventually I doesn't change, you want to make I a constant. I mean, we like that. That's good. It means you can't screw up by accident. Or can you? Let's find out. Let's do struct person struct, and we'll do var name string and var age int. And I'll say in here var Taylor equals person struct name Taylor Swift age 26. Taylor.name equals Justin Bieber. Should be an extreme surprise that Swifty's going to a concert. Print Taylor.name. Yeah, it's fine. You can change that if you want to. That's cool. But watch this. Let Taylor. Now, what you can compile. So it enforces the constants at the property level. Now, to demonstrate this, I want to show you how it looks with classes. So we've got struct person struct. Let's make class person class. And we'll do the same thing. Var name string, var age int. You have to hand roll your initializer because it's a class now. So int name string age int. Self.name equals name, self.age equals age. And down here, I'm going to say person class. And it's fine. The errors go away. It's totally cool. Even though I'm making it a constant, it still merrily changes the property. It does not enforce the immutability. So using a class or a struct affects the way we approach immutable values. And this matters. So I'm going to try and show you all the possible options here. So if we had Taylor as a person struct, like that. Let's make it var. There we go. Taylor1 is a person struct, a variable person struct. So I can say Taylor1.name equals Justin Bieber. Swift's cool. I can say Taylor1 equals person struct, struct, name, Justin Bieber. I cannot write Bieber, age 22. And it's cool with that. You can change a property or change the whole value. That's cool. If we had a constant struct, so Taylor2 equals person struct, name Taylor Swift, and I'll copy and paste this stuff because it's getting silly. Taylor Swift, there we go. Constant struct now. If I try and say to this thing, Taylor2.name equals Justin Bieber, or the whole thing, Taylor2 is person struct Justin Bieber, either of those will fail. You cannot change properties, you cannot change the whole value. Both are bad. If I'd made it a class, let's make it a variable class, we'll do person class. Call this one Taylor3, Taylor3, and person class. Like that. Have a little think. Yep, cool with that. So when it's a variable class, you can change a property or the whole reference. And when it's a constant class, like that, you will see this line is cool, this line is not. So it enforces that the reference itself will not change. The things inside it, fill your boots. So obviously the most important point for most people with value types is arrays, where var and let effectively stop you from making immutable arrays. But it does mean using the right thing means Swift can optimize your code more effectively. So if you can use let and you can use structs, you get this situation here. The most optimized, the most safe. You can't change anything, bud. Recommended. And that is value types. Yeah. Are you aware of arc?
Yes.
Right. So what arc does is it keeps track of how many times an object's referenced. Yes?
Yep.
So it'll say, this button has 3 people pointing at it strongly. One of them goes away, it's now 2. One of them goes away, it's now 1. The last one goes away, it's 0, destroy. So it has to add, remove, add, remove, add, remove constantly. That's what arc does. Structs do not use arc because they always have exactly one owner. So reference count's always 1. There's no point having arc there, okay? So the struct itself is never reference counted. It cannot be, it's pointless. But the things inside it need to be. So if a struct's put somewhere, that view is now somewhere else, add 1 to it, add 1 to it, add 1 to it. So it has to add 1 to each of the 3 properties. If the whole thing were a class, it doesn't reference count the inside of it, it reference counts the class itself. So rather than doing 3 arc plus 1s, it's 1 arc plus 1. 3, probably not too bad. 10, 15, 20, bad. An actual problem. So you want to, if you're in that situation where structs have reference types, there's quite a few of them and you move them around quite a lot, probably make it a class to be more efficient. Next.
Sorry, one other question about the OS, the values for struct. Is there any way, do you know if there's any way to implement copy on write, like for custom structs?
Well, sorry, I had a go at this. I had a go. It's not impossible. It's not easy, but it's not impossible. And I don't think it matters. Because, so it's a common misconception that people think Swift has copy and write baked into the language. It doesn't, right? It's literally written into arrays and other value types. But unless you happen to have an extremely custom data type, it'll use copy and write anyway. So if you're using an array as a property, copy and write. If you're using a dictionary, copy and write. You get, unless you've got something really obscure, like custom file handle or something here you want to do copy and write for, you're basically okay. So I did a lot of work. I spent a few days writing a chapter on this, and I thought, actually, this is never going to do anything. And actually, there used to be on the, where is it, Swift Wiki? The Apple Swift source code wiki, I think. There was an example of this, and someone put a comment saying, we don't need this. This is a lot of work, but not any benefit. It might still be there. I'm not sure. Come on, be brave. Win, you haven't chosen anything yet, have you? You've chosen quite a few.
Guard.
Guard? Okay. Oh, do you know what guard is, by the way? Awesome. That's right. It's awesome. Right. Let us find, oops, daisy, guard. Guard is right the way back here somewhere. Generics, guard. Boom, really easy. Guard is easy, which is good. We like guard. So, guard effectively is early returns. That's what it's doing. And it's going to go nuts on me. It's early returns. Are you familiar with early returns? Yes? Who is not familiar with early returns? Start with that, perhaps. You all know early returns. Fine. So an early return is just a simple way of avoiding the happy path. You want your method to be quite clear what it's trying to do, and the sooner you can bail out of that, the better. Now, this is a, what should we call it? Discussion point. Some people believe every function, every method should have exactly one return. Fill your boots, you know, I don't mind. What I would say is that I think guard is idiomatic Swift. It's very natural Swift. It's encouraged by the Swift team. So stick with guard. It also reduces your indent level, which it sounds petty, but I think it's quite important. It makes your code easy to read by bringing it all in one step. If you have if for your whole method, you're just pushing it in by one straight away. Guard, of course, ditches that immediately. It also makes your happy path clear, because guard satisfies the preconditions at the start of your scope, your method, for example, gets it out of the way. All my preconditions are satisfied, I am happy, I want to continue on now, and the happy path is what remains. The rest of my method is a happy path, the golden math. It's very clear. And again, broken record I know, this is about intent. What are you trying to do? How does this actually want to work? And this is important. This if is not just some random check, blah, 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 blah. This is a precondition. The method should not go any further. The scope should exit if this is not true. And in fact, Swift enforces that. If you have a guard and do not return from the guard, do not break out of the current scope in the guard, it will not build your code. It will fail and refuse to build. Plus, unwraps stay in scope always, which is helpful. So if you are doing a equivalent of if-let, guard will unwrap the data and keep it in scope even after it's finished, which is, I don't think that's commonly used, I'm not sure. But a bonus, the one folks don't seem to know for some reason, is that it works in any scope. It's most commonly seen in methods. It works in loops. It works in conditions. You name it, it's going to work. So guard is very, very commonly used for a good reason, which is that it does a lot of things back to back. Let's try and switch to screen sharing again. Yeah. Oh, this has lost internet yet again. You'd think internet would be a solved problem in San Francisco, wouldn't you? But there you go.
Not in America.
No, actually, I'm staying in a hotel down the road from here, and it's the first place I've been to, I think, in recent memory, where they've had fast, free Wi-Fi. Because normally it's like, yeah, it's $10 a day. Like, what year is it? Well, come on. It's Hotel Majestic, so about 5 minutes walk from here. And it has actually fast. I can FaceTime my wife properly for a change, for free, which is surprising. I was blown away. Anyway. Struct plus instruct. Fine. So, where are we? Right. So, we're going to look at guard. So with guard, I said already, you can do it with scopes and so forth or other things, that's fine. We're going to start off by looking at guard, sort of the classical guard that I hope at this point you are all using. Exit a method, right? So if we had something like, there we go. If we had func give award to name string, we can have a guard in here. Guard name is Taylor Swift, else return, and perhaps even print an error. Print lol what. Otherwise, print you're the best. That is almost certainly how you're using guard today. That's a sort of canonical guard example right there, which is fine. But guard also lets you optionally unwrap stuff. So we had in here, you know, give award to Taylor, like that. You can use guard to, not Taylor Swift, sorry. You can use guard to unwrap things. So normally it has something like this. If let name equals name, because optional, then unwrap and continue. And if you're using if let, what it means is inside here, inside these two braces, you are able to use the unwrapped optional name. Of course, unwrapped name would be a bit clearer, like that. Inside here, that's valid and unwrapped and ready to go. Outside of here, at this print block here, you cannot use name anymore, unwrapped name. It's gone away. It's only valid inside the braces, that scope there. Guard flips it around. Guard unwraps it and keeps it in scope. So if we had guard let unwrapped name equals name, else, whatever, it would ensure it exists and stays in scope. You could write, you know, unwrapped name. That's also the way guard's commonly used, to check and unwrap and early return if needed. But guard can do much more than that, because guard can work in any scope. For example, loops and so forth. You can have guards in loops, you can have guards in if statements, you can have guards in, well, everything you want, quite frankly. It doesn't really matter. For example, we could have, let's take what's cut out for a start. It was out, there we go. We could say for I in 1 to 100. Guard I% 8 is 0. Else continue. Print I. So now it loops through all numbers 1 to 100 and only prints out the ones that evenly divisible by 8. That's what guard does. But it lets you, as long as you exit the current scope, which continue does, which break does, which return does, it's fine. You can use it in loops, in conditions, in methods and so forth. And the best bit is, if you don't have that, if you do print hello, it will literally refuse to build, which is great. That's guard. It's really simple. In my own code and in my own books, I never, ever, ever do more than one. I would rather say guard let foobar baz return, guard let return, guard let so it's clear at a glance what you're trying to do. And the same is true of if let. You can do multiple unwraps and then conditions and stuff, and it gets very hard to read. You'll see folks try and do it, so they indent it and sort of use space to make it line up nicely, and you're fighting a losing battle. I prefer to just do guard, 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 guard. I mean, the difference in performance is nil. So there's no reason not to, it just makes no sense.
Okay. Thank you.
Who hasn't chosen something yet? Steve, chosen something yet?
Lazy loading.
Lazy loading, okay with that?
Ooh.
Lazy, I like lazy at this time of the day, don't we? 3:30, everyone's tired. Let's try and find lazy loading. So, in here somewhere, where is it? 8. 8, 8, 8, 8, 8. 8. Come on, right references. There we go. Okay. Lazy loading. So, lazy loading, like closures, is pervasive in iOS. It's everywhere. It's one of the most standard optimizations you'll find in iOS, or even AppKit. Do as little work as you can, as late as you can. And this is everywhere. But even so, it was all hand-coded in Objective-C. You had to work in it by hand, which of course sucked. No one likes doing extra work. But this is important. It was used everywhere. For example, if you create a view controller and you haven't presented it yet, its view hasn't been made. Its subviews haven't been made. They don't exist. They're all nil, empty. When you finally present it, then iOS is like, I better make this thing, and starts building the views and the layouts and storyboards and it will call if you did load and start using it and so forth. But it's everywhere in Objective-C. So when it came time for Swift to be developed, they thought, right, we're using this a heck of a lot. We need a better way to do this. So it's easier in Swift. And you can make it use closures or methods if you want to. Doesn't really matter how you do it, whatever works best for you. Plus, you can also apply them to sequences if you want to. And there are even singletons. Lol. Singletons still exist. I should say up front, I am no friend of singletons. I really don't think they're any good. They get vastly overused by people, which is a real shame. They do exist in Objective-C, but realistically, when I see them being used, they're effectively global variables. And people will say, well, global variables are bad, but singletons are totally cool. I like singletons. Well, meh. So in iOS, you find them occasionally. You'll find it in a UI device, you'll find it in a UI application. They are used sometimes, and Apple does use them sometimes, but not very often. That's the key here. They use it only when it really, really, really means there's only ever exactly one of these things guaranteed, never more than one. How many iPhones is my app running on? Exactly one. UI device, singleton. Get that. UI application, again. How many apps? Well, it's my app. There's one app. Singleton. So you can say UI application not shared. And it wasn't trivial in Objective-C. You had to work at it. You had to add the code to yourself everywhere you need to have them by hand. Whereas in Swift, they are, to coin a Jobsism, insanely easy. Is anyone using Singleton's Lazy right now? Give me an idea. Is anyone using lazy stuff right now? Any lazy users? Oh, you're not lazy people, lazy users. 1, 2, Steve. 3? That it? Okay, cool, that's all right. I'll show you. It'll make sense shortly, all being well. Right, so let's have a look. So, let's try and screen share. Oh, I've been bit off the Wi-Fi again. This is rubbish. This is truly rubbish Wi-Fi.
Let's go to your hotel.
The problem is I can't even use my phone because the 3G for me here is shockingly bad. I don't even know why it's that bad, but
3G sucks.
well, no, apparently it's San Francisco. It's pretty good, isn't it? Here, I thought.
Well, we're kind of in a basement too. Yeah.
Are you making excuses that are valid and sense reasonable? I don't think so.
You're in America now.
Thanks for that. I'd spotted that by the vast flags flying everywhere. So I wasn't sure where I was. Have you seen the Nissan building just around here? With like a flag that's sort of 4 people high. It's sort of vast.
Is it a car dealership?
I think, well, Nissan. So,
I love flags.
oh, in the middle of the city though, come on. I don't know. Anyway. I used to try and get on the Wi-Fi. This is pathetic. This is absolutely pathetic. Not drilling anymore, but they can't get good Wi-Fi. Anyway, we'll try and do it without. So let's zap that and switch to mirror displays. There we go. And scrap all that. So, like I said, these things are absolutely everywhere in iOS. They really are endemic. What that means is they're so common, you need to be using them if you want to benefit from the same performance advantages you see in UI view controller and similar. So let's try a very, very simple class here. If I had class singer, like this, I had a name. I'll say let name is a string. I'm going to say init name string, oops, self.name equals name, like that. Now if I wanted to have, this is a trivial example, a reversed name. What is person's name in reverse? I would say func reverse name return string. I'd write return name backwards is string name dot uppercase dot characters dot reverse, like that. Reversed, like hello, that. That is that right? It's complaining. Why have you wrapped across 2 lines? I don't like that very much. I can't see what you're doing. Ah, that's why. All right. Ah, missing a bracket. There we go. Fine. So we can have that. And that's fine. That will calculate the name in reverse. So we can say something like, it's still whinging. Why are you whinging still? Until it's string literal. Oh, come on. String, name, let's jack the uppercase, it's pointless. Characters, reversed, end. That's it. That's it. Yes, fine. Okay, it's happy now. If I had let Luciano equals singer, name Luciano, that, I could say print Luciano.name or print Luciano.reverse name. It should say reverse is whatever. Doing well. Thinking. Come on. There we go. So it reverses it. Trivial, right? But if we had some actual serious work to do here, some actual intensive work, took more than a fraction of a millisecond to run, what happens is when you use that again and again and again, you are repeating the work. Repeating, which is not great. No one wants to repeat work they don't have to do. So you might think, well, maybe we'll just store the reverse name. So we can have up here let reverse name string, and then initialize it once when we need it. This self.reverse name equals that. That works fine too. And now this is not a method anymore, it's a property. So now it's faster, because it's not running the same code again and again and again. It runs it once and we're happy with it. And that's a performance improvement if you use reverse name. If you think about it, if you had this code, we never need the reverse name. So we're now doing work we don't need to do. So it's good in some way and bad in other ways. And that is where lazy comes in, because lazy lets you choose to do work and do it only once, and it will cache automatically the returning value. So let's try it now. We're going to start off with a lazy closure, because what you can do is you can say in here, scrap that, and just keep the code at least. And I'll write lazy var reverse name and continue on. And just by adding that one keyword, it becomes lazy. There's no write your own boilerplate code here. Just that one keyword makes it lazy, which is nice. So we could say lazy var reverse name, it's a string, and give it a closure. And I'll just put in here the return thing we had before. Return self.name backwards is self-name characters reversed. You do need to add open and close parens for the lazy. This is what's called an immediately applied function. And now you can use reverse name, like a property, like that, and it's fine. If you never use it, it's never called. If you do use it 5 times, it's only run once. Swift will automatically say, I've got a value already, and use the cached value. Or if it's never requested, it'll never be used. So this is essentially a non-escaping closure here. This can't escape ever. So you don't have to worry about having self in there and getting a hideous retain cycle and so forth. It's safe to use. So that's a lazy property. You can also have lazy methods. Now,
What if you set reverse name? It's a variable, right? So,
what do you want to do?
well, if you set it, so it's just setting the initial property, and so you can essentially override it.
You mean just like nuke it like that?
Yeah.
Yeah, if you're desperate to.
Okay. So, but that would only get called one, like.
This is only the initial.
Does it get called once, or is it when it's nil, it gets reset?
That's
Well, if-
legal, there's no setter.
Yeah, but if you're setting it, it's different, isn't it? It's a different thing entirely. You can set it again and again and again if you want to. Bob 1.
There's no set there.
Well, so I'm saying, like, if you were to call, like, if you were to print it, set it, and then.
Oh, so I'll tell you. So print it. Print Luciano.name. Set it, then print it.
Reverse name.
Oh, sorry.
So- and
reverse
then-
name.
Well, like, I'm
Reverse
saying, like,
name.
it's only getting called when it's, like, initially when it's first being used, right? So it's not, it doesn't get called if it's like nil, for example.
Doesn't get called as nil.
So, like, because this is a variable, you're able to set it so that, like, the only time it's lazily extension is when it's
So if you
nil.
send it to Bob before the first time you call it, what happens?
You mean like
I guess-
that?
Yeah. Is that what you're
Okay,
asking?
yeah. So I just want to know when, like, when is this method called?
Well, all you can do is put in here.
This is not good.
Print. It's called. Sorry?
This is not good.
It's bad, is it? You'll buy yourself on that one. Is it going to do anything?
Awesome, it's not.
Not putting that at all, I'm afraid. Not doing it. Helpful. Anyway, so the complaint people usually have with lazy, and perhaps this might not be your complaint, but this is the most common complaint, is that it kind of clutters properties and methods into some sort of blob, right? You've got a property here, but it's got a lot of code inside, and it can make your code quite ugly because you want to have nice properties, beautifully aligned, and loads of methods, right? So what you can do instead is to say, actually, I want to have reverse name call a method as part of its lazy creation. So if I have in here, this is for a second, if I have private func get reverse name, like that, I'll just do self name here and string name like that. I can tell the lazy thing to point at that closure. I can say that function, sorry, self dot get reverse name like that, and point it. So you get the cleanliness, sorry, of your organizing if you desperately want to. That's whinging because that shouldn't be there. You're separating, properties and methods nicely. Why is it complaining now? You horrible
Where
thing.
is that defined?
Ah, yes, good point. That should be a string here. String. Boom. You can separate it nicely so you've got all your properties up front, like that, then your methods. A lot of folks prefer that, and I probably agree actually.
Well, I have a question.
Yeah.
I know I've seen, what if you take out the word lazy? Does it still compile?
From where? Here?
Yeah.
Try that.
Okay, so there's, so I guess the syntax that I remember is not in a class, but in a struct, where you can say var variable name, and you give a getter and or a setter, right? And if you just give a getter, you don't have to label it with the get keyword.
Yes, that's true. You can do it in classes too.
Oh yeah, so how come it's complaining here?
What are you trying to do? It'll tell you why it's complaining.
What?
You can't use it here. You can't use it
Var
inside
reverse name is
initializer.
a complaint on that line.
Yeah, it's saying here, if you look at the error at the bottom, it refuses to do it. You can't use the proper initializer here. Self isn't available yet. You can't do that. The initialization problem is tricky in Swift. The way you initialize things. What it's trying to say to you is that this bit of code will run before this bit of code,
Right, so it's not a syntax error, it's something.
which is illegal in Swift.
um,
Yeah, it's a semantic
Okay,
error.
but this is legal syntax. If get reverse name did not depend upon the initialization,
Yeah,
this
correct.
would compile.
Yes. Yes,
So it's because you're calling a function?
correct.
or the initializer?
Which is against the rules in Swift,
For
against
itself.
one of the many rules in Swift.
So if you put that in line,
Yeah.
What do you want? What, this one? That in there? Nah. Nah. It will laugh, I expect. Yeah,
But that's because it depends on name.
correct. That's fine. But only because it's trying to read a property that won't have been set yet, effectively. So methods. So like I said, you can also use these things singletons if you want to. And I said already, they're not particularly fond of singletons, but Swift makes them extremely easy, which it makes them less horrible. For example, have a look at this. If I did a class called music player, and in it, all it's going to do when it's made is say print ready to play songs. That's all it's going to do. When it's made, it's ready to play. Now if we had a singer class as well, class singer, in it, and I'll say in here, print created a new singer. And now for the singleton. With a singleton, we can add one line of code here inside the singer class. We can say static let music player equals music player. And that's it. So if I were to do this, if I did let Taylor equals singer, it'll think about it. It should say create a new singer right here. And then if I said Taylor dot music player, sorry, single note music player. Now it'll say ready to play songs. Lazy. Automatically lazy. The singletons are only created when they're first needed. And they're static, so they're shared afterwards, and they're let. They ain't going to change afterwards. You get all the power of singletons, lazy loading, that kind of thing, automatically. They're lazy out of the box. Is it not?
No, because you could have a static let music player in some other class and it would be another instance.
Oh yeah, so that, yes, of course, that's true for any singleton, isn't it? You can just copy it and paste it. I could make another UI application if I really wanted to. I wouldn't do it, but I could do. Singletons are enforced through semantics, ultimately. UI application is just a class, like anything else.
So a singleton is a class that may only have one.
Exactly, yes. So that is singletons, which is basically automatic in Swift. You just use static let, and it understands that to mean I will lazy load these singletons here. You can also do lazy sequences. I showed you them briefly before. We had filter and map, if you remember. We had like 5,000 things, filter and so forth. I want to show you again how they work because they're quite brilliant and they're quite surprising. So try and watch carefully. We could write a naive function that calculates a Fibonacci number at a particular point in the sequence, recursively. So we could write func Fibonacci of num int returns int. If num is less than 2, return num. Else, return Fibonacci of num minus 1 plus Fibonacci of num minus 2. It's a naive implementation. It doesn't cache the result as it goes. So it's doing all the adding of Fibonacci num minus 1. All that adding is being ignored Fibonacci minus 2, which is obviously a mistake. It's not brilliant, but it's fine. We can try it out. We can say let Fibonacci sequence equals 0 to 20 inclusive dot map Fibonacci. And then print Fibonacci sequence, item 10. It'll have a little think. $29,000 times to get another 55. Okay, so it's obviously inefficient. It's naive. This is a ridiculously fast Mac. This is as good as it gets, as far as I'm concerned, and it still took a little while to calculate that. If I did just 2 numbers higher, it goes from 29,000, 10,000, 20,000, 30,000, 40,000, 50,000. This is a long, slow operation. 75,000 times I had to run this function recursively to calculate a single number, 55. I'll come back next year and let you know how this worked out. It's slow, it's naive, that's on purpose. In this particular case, we don't really care what Fibonacci of 198, 197, 196, 195 is. We just don't care. What we care about is number 10. And the chance to know the other ones. And that's easy thanks to lazy sequences. I can change this code to be lazy.map. It'll think. It'll complain, naturally, because the result no longer is an array. I have to map that to an array, like that. Boom, 55. 1999, 55. 1999, 55. It's extremely fast. Because the lazy thing, again, attaches your closure, your code you want to run, to the sequence, and calculates it on the fly. So I'm looking for the 11th item, number 10 there, and it'll go, okay, now calculate just that one number. And forget 11, 12, 13, 14, 15, up to, you know, what have we got here, 200,000 or 2 million. Ignore the rest, just do the one we really need, which is great. So it's significantly faster in some situations, but not all. If you remember, we had the lazy property. I said reverse name, reverse name, reverse name, reverse name, reverse name, blah, blah, blah. We can call it again and again and again, and Swift will automatically store the result of the value in the property like a stored property, right? It caches it. It does not do that for lazy sequences. So here, if I had a sort of middling high number, like say 19, and then used here, let's just put one eye on here again, there we go. It'll run, see, 4181. And watch this. Doing lots of work. It does not store the results. If you're feeling technically minded after the functors and monads, it does not memoize for you.
So, I'm a little confused. What you're making lazy here is the array, not the Fibonacci function.
Correct.
Is there a way to make the function lazy? Or memorize it, rather.
Of course, you can memorize it by hand if you want to. You have to do it by hand, though.
Oh.
You have to write the code for that. And I think, actually, Apple did give the code out for this on one of the WWDC talks. I don't remember which
For
one.
this particular function.
No, for general. I think it was a general purpose memorization for sequences. I think. I remember. But it was at least Swift 2, if not Swift 1. It was a while ago. So you've got to be careful. It's fast if you want one value or two values, whatever it is. If you've got the same value again and again and again, it's going to be slower. It's probably worth computing them all up front and storing it and reusing it from there. And that is lazy sequences.